Welcome to Hartman Math. Today's lesson is 5.5 nth roots and rational exponents. So example number 1, remember this one from before. So this is a quadratic equation back from unit 3, where if we're going to solve that, square root method would be a good one. We could square root both sides. Don't forget the plus or minus. We'll review. Now, which root did we take? Since we were trying to undo squaring, we took the square root. And that's not really indicated here in the notation, because the root that we take, there's a number that goes right here that tells us which root we've taken. But if it's a square root, we tend not to write anything. It's standard notation not to write anything. We took the second root, so there's really an invisible 2 right there saying that we took a second root, a square root. And we don't write it there, but it is there, just like if we're talking about an exponent that's not there, x to the first power. Same thing here, but it's an missing, and it's called the index. It's a missing index of 2. All right, solve example number 2. This time we're trying to undo the nth power. So just like here, we're going to take a root, and we want the root to match the exponent. So we're going to take the nth root on both sides, and we put that right there, and that's our index. The n goes right there. So make sure, notation-wise, when you write it, it's right there in the notch. Don't let it drift out in front where we might confuse it with something else. So be very careful with your notation. All right, so here's our rational, which means fractions, exponents, conversion kind of diagram here. If we have a base that's raised to a power that's a fraction, we can rewrite it into root form. Okay? This one here doesn't really connect. We usually just use these 3 right there. So really important to memorize and know. So we're talking about roots. The denominator is the index, so it's going to tell you which root we're taking. The numerator is the power, what we're raising it to. So usually we go from here to here. We're going to take the nth root. That comes from the denominator. We're going to raise to the power of m. We typically do it this way. This is also true. We typically would want to take the root first, then raise to the power. So, index tells us which root to take. There's the power. So if we can, without a calculator, evaluate this, 9 to the power of 5/2, we're going to want to change that into this notation. Since the exponent is a fraction, we're going to rewrite it in terms of radicals, roots. That tells us which root to take. So we're going to take a square root, and then we're going to raise to the 5th power. So notice I didn't write the index here. I didn't need to because it was a 2. Anything else and you got to write it. So what's the square root of 9? 3. Raise that to the 5th power. So 3 times 3 times 3 times 3 times 3. We get 243. There's our answer, 243. All right, pause the video here while you work through this one. All right, if we remember back to lesson 5.1, our exponent properties. Anything missing an exponent gets a 1. Rule 2, if there are parentheses, now we don't have that. Rule 3, level change, we got to do that. So this turns into 1 over 8 to the 2/3. Then we can do and rewrite in terms of roots. So we did a level change. Now we're going to go 1 over. Don't forget the fact that from this point forward, it's probably going to be a fraction. So 1 over, here's our index. Cube root of 8 raised to the 2nd power. The cube root of 8, what could we cube to get 8? That would be 2. 2 squared is 4. So we got 1 over 4, final answer. Now, approximate with a calculator. So not simplify, but approximate. Get a decimal approximation, nearest thousandth, which means 3 digits after the decimal. So how are we going to type this in? Well, our first option is we can type it in like this. Now, we do not want to use the square root button because we're not doing a square root. We're doing a fifth root. So in this case, here's how we type it in. If you have a Texas Instrument basic calculator, like this. And some of the others should be pretty similar to this. So if they're not exactly the same, pretty similar. So first thing we're going to do is we're going to tell it what root to take. We're going to take the fifth root, we're going to type in a 5. So then we're going to hit not the square root button, but the X root button, which is an unknown root. So that's usually going to be the square root, or the, in this case, the up caret, but it's blue, so I have to press second, and then the up caret. And that gives us the X root. And then, unlike on this calculator, unlike when we do square roots, which would open parentheses for us immediately, this one doesn't have it. Since it's just 15 that we're doing, I don't think we need the parentheses. So we can type in a 1 and a 5. Close parentheses if you need to, but I don't think we will need to here, so we probably don't even need that one. Hit equals, enter, we get our value. Or we could change this back into exponential form, say it's x to the power of, since this is a root, would have to be a fraction. That would be the denominator. Since we don't see a power, it would be 1. So this is the same thing as 15 to the 1/5 power. So we could also just do 15 raised to the parentheses 1 divided by 5. That'll work too. Well, let's see it on a calculator. I'm going to go with this way, see what it looks like, see what we get. All right, so as we said, we're doing the fifth root of 15. Tell it which root we're going to take first. Then we want the X root here, so we're going to press second up caret to get the X root. So we're now doing the fifth root, but we don't need the parentheses. We're just doing 15, so 15 equals. And as far as our rounding goes, 1.718. We're going to look at the next digit to see if we're going to keep it as an 8 or round it up. Since that's 5 or higher, we're going to round that up. We want to get 1.719. There we go, 1.719. Example number 5. Now let's see if we can use these other roots to solve equations. We're going to want to isolate like we've done before, so let's get rid of that 3. Let's divide both sides by 3. Now we want to get rid of an exponent of 4. So we're going to take a fourth root on both sides. Now, just like on a square root, we're going to want to do plus or minus here. We do that not on any roots, but on all even roots. Even roots only. So x equals plus or minus the fourth root of 14,641. Let's go ahead and now try to do that on the calculator. Remember, type in a 4, second up caret to get the x root, 14,641. See what you get. We should get 11. So there we go, x equals positive or negative root 11. The reason why the negative also works is because we're essentially doing, that would mean negative 11 times negative 11 times negative 11 times negative 11. If there's 4 of them to get the 1461. Negative times negative is a positive 121, and again over here, positive. So in this case, if we have an even number of negatives being multiplied, the result comes out to be the positive. It's not true if we're doing an odd number of negatives. We wouldn't get a positive. And example number 6, isolate. There's nothing outside of the parentheses. So we have to deal with the exponent next. We have to undo the third power. Let's take a root. Which root are we going to take? Third root, otherwise known as cube root. So we'll cube root both sides. That is an odd root, so we have no need of plus or minus. Now, here, unlike when we were doing square roots, the square root of a negative is imaginary, out comes I. That is not true for odd roots. It's not true for odd roots, because if we were doing the cube root of -8, the answer is -2, because -2 times -2 times -2 makes the -8. So there's no need for any kind of imaginary. So any odd roots of a negative, we can pull out the negative as a negative, not as I. That would be for a square root. It just comes out as a negative. And then we can add the 4 to both sides, put it in the front like we usually do, and then there's our final answer. Out came the minus right to there. Because if you take an odd root of a negative, the answer is negative. That's it for today. I'll see you next time.